Okay, hello everybody. Today we are going to be doing a differential equation, cosine x times dy by dx plus the sine of x times y equals cosine squared of x. So let's just jump straight into this, okay? So we're going to say solution. And first of all, we're just going to divide out by cosine x. Okay, we're going to divide by cosine x because we have a cosine x here, we have a cosine x here, and we have a sine here. So sine x over cosine x will give us tangent x. So that's pretty nice. So we're going to do that, okay? We're going to divide out by cosine x. So this gives us dy. Actually, we're going to write dy by dx as y prime, because that's just going to be a bit nicer, a bit quicker. So y prime, okay, the cosine x's cancel, so we just get 1 times y prime plus sine x over cosine x tangent x. So it's going to be the tangent of x, tangent of x times y equals cosine squared over cosine x. Well, it's just going to be the power. We're just going to reduce the power, so it's going to be 2 minus 1, which equals 1. So it's cosine x to the 1. So it's just cosine x, okay? So that's nice. Now, notice that this is in our general form for the integrating factor, which is y prime plus p of x, a function of x, multiplied by y equals, say, q of x. Okay, so we've got that. Now we're going to identify our integrating factor, which is just going to be e to the integral of p of x, which is tangent x. So it's going to be r of x, our integrating factor, is going to be e to the integral of p of x, which is tangent of x, dx. Now this integral isn't too hard. I actually did it in a previous video, so I'm not going to go through it here. I'll just give you the result. But if you want to go see how I did it, you can go look at the other video. And it's just the natural log of secant of x, which simplifies down to secant x. Okay, because these two cancel out. So yeah, the result of this integral is natural log secant x. So we're going to multiply out by the secant x, which gives us secant of x, y prime plus secant x tangent x times y. Don't know what's going on with the x there, but you know, we'll go with it. Equals cosine x. Secant x is just 1 over cosine x. So this is just going to give us 1, which is quite nice. Okay, we did not mean to do that, but we're just going to go with it. So this equals 1. Okay, very nice. Now notice that this is none other than the differential of y times secant x. Okay, you can verify this by taking the derivative of this. It's just going to be the product rule, fg prime plus f prime g. So we're going to do f, which is, we're going to do derivative of y, which is going to be y prime, times the secant of x, because we're leaving that function, plus derivative of secant x tangent x, leave the second function, which gives us y prime secant x plus secant x tangent x y. So yep, that is what we've got up here. So you check that that's the derivative, and yeah, so now we're going to set this equal to what we have, which is 1, and now we can just integrate this to get rid of this. Integrate with respect to x, integrate with respect to x, get some nice cancellation here, and this gives us that y times the secant of x equals none other than, well, this is going to be x plus our arbitrary constant of integration, c. Let's call it c1. And now we're just doing a little bit of algebra. To get y on its own, it's just going to be y equals, we're dividing out by secant x, so we're timesing by cosine x. Y equals c1 cosine x plus x times the cosine of x. I don't know why I've done that actually, let's just write. There we go. So y equals c1 cosine x plus x cosine x, and that is our solution for today's differential equation. This wasn't too hard, it was quite nice to do, a bit of an integrating factor, quite a nice integrating factor actually, but yeah, hope you enjoyed the video, maybe you learnt something new today. Please leave a like and subscribe, and yeah, thanks for watching.